Willkommen alle zusammen. Ich freue mich sehr, dass wir es geschafft haben, noch so einen Science Talk hier bei uns auf der IRIS hinzubekommen im Rahmen unserer Ship-It-Back-Tour. Wir werden den Rest des Talks in Englisch machen, da wir internationale Gäste haben. Jetzt einmal hier die Frage, ist das für alle okay? Wenn nicht, werden wir stellenweise übersetzen. Sieht das so aus? So die wichtigsten Parts übersetzen? Ja? Ja. Okay, aber wir werden es erstmal im Englisch probieren, würde ich vorschlagen, und dann, wir sind ganz relaxed. Wir sind Greenpeace, wir sind relaxed, bei uns geht es darum, was zu verändern, und wir gucken, wie es passt. Das heißt, einfach mal gerne die Hand hoch machen. Dann begrüße ich erstmal alle ganz herzlich hier bei uns, auch auf unserem YouTube-Kanal. Wir streamen das Ganze heute, weil wir hier noch einen kleinen Teil der Gäste haben. Wir wollen es natürlich für alle zur Verfügung stellen. Wir sind hier im Rahmen unserer Ship-It-Back-Tour. Das ist das internationale Greenpeace-Projekt, wo es jetzt darum geht, dass ihr wisst, dass wir ein riesen Plastikproblem haben. Wir haben eine Plastikkrise, und diese Plastikkrise wird am deutlichsten in Südostasien. Und wir sehen aber, dass in den europäischen Ländern recyceln alles. Das Problem ist ja in Südostasien, da liegt der ganze Müll. Die Menschen recyceln nicht, die bringen das nicht weg, da landet es im Meer. Und das sind ja nur diese drei Flüsse, die den ganzen Plastikmüll in die Meere treiben. Deswegen müssen wir nichts machen. Und wir sagen, das ist totaler Schwachsinn, denn wir wissen von Studien, wir wissen von Ergebnissen, dass es nicht nur der Fall ist, dass deutscher Müll, dass europäischer Müll am Ende hier gar nicht recycelt wird. Das ist halt eine Recycling-Mythos, das ist nur ein geringer Teil, der recycelt wird, ein großer Teil wird verbrannt oder sogar deponiert und geht sogar nach Südostasien, geht sogar nach Manila, geht in die Philippinen und wird am Ende dort verbrannt oder illegal gelagert und kommt über solche Umwege wieder ins Meer. Und der große Teil ist natürlich, dass dieser Plastikmüll dort nicht entsteht. Dieser Plastikmüll, diese Sachen, die dort entstehen, die werden hier produziert. Die werden von großen internationalen Konzernen produziert, von Firmen wie Nestlé, Unilever, von Procter & Gamble. Das sind Firmen, die diesen Plastikmüll, dieses Plastikmonster kreiert haben. Und diese Firmen bringen diese Single-Use-Plastikprodukte nach Südostasien, überschwemmen ganze Regionen mit Plastikmüll, die keine Infrastrukturen haben, um mit diesen sinnlosen Verpackungen umzugehen. Und dieses Monster, dieses Plastikmonster, das hier kreiert wurde, das machen wir sichtbar. Wir sind vor Ort 2017 bei Greenpeace im Rahmen der Break Free von Plastik Kampagne von dem Projekt vor Ort, hat einzelne Strände, zum Beispiel 2017 das ein Projekt auf Freedom Island, eine Woche lang einen 200 Meter langen Strand gereinigt, aber nicht einfach nur ein bisschen gesammelt. Nein, was wir machen, ist, dass wenn man oben anfängt, sieht, dass es einen ganzen Meter Plastikmüll ist. Ja? Das ist Sand. Und wenn man anfängt zu graben, sieht man, es ist eigentlich eine Plastikgeografie, Geologie. Es ist also wirklich ein Meter tief, wo schon dieser Plastikmüll sich angesammelt hat. Und was wir machen, ist, dass wir ihn zurückbringen zu den Verantwortlichen. Wenn wir zeigen, dieser Plastikmüll ist nicht da entstanden, es sind einzelne Firmen. Und wir haben ein Brand Audit gemacht, das heißt, es wird geguckt, welche Firmen sind denn verantwortlich? Was ist denn Nestlé? Was ist Danone? Was ist Unilever? Und dieses Monster, ihr habt es vielleicht draußen gesehen, dieses Monster ist jetzt zurückgekommen nach Europa. Dieses Monster kommt zu den Verantwortlichen. Und diese Verantwortlichen haben sich jetzt ihrer Verantwortung auch zu stellen. Und darüber berichten wir heute von dieser Ship-It-Back-Tour. Wir sind heute halt hier vor Ort. Ich begrüße ganz herzlich einmal meinen Kollegen Manfred Sanden, Chemiker von Greenpeace, seit über 10 Jahren dabei, und wenn es um Chemieunfälle in Deutschland geht, bis zu Chemiekatastrophen in Südostasien, wenn wir zum Beispiel im Rahmen unserer Textilkampagne, der Detox My Fashion Kampagne, gucken, welche Chemikalien eingeleitet werden durch die Textilindustrie in China, in Bangladesch, in Indien, um diese Sachen aufzuklären, ist Manfred immer ganz vorne mit dabei. Ich begrüße Actually, he joined us on the Beluga, that is the other Greenpeace ship we're here, and we're doing microplastic samples. And I just want to make it proper so I better read it. He's a scientist, yes, okay, you didn't know that. He's working in the Netherlands actually, and with the NIOZ, it's the Royal Netherlands Institute for Sea Research at the Utrecht University. And actually he is, can I say, microbial ecologist, and he's since 1985 studying and teaching about different kinds of marine systems as a researcher and a professor. And he is participating on over 70 research cruises collecting oceanographic data, including plastic, marine debris in the Pacific, Atlantic, Caribbean, and in the Mediterranean. And what I love so much about him, as there's so much plastic already out there, for me, it's like it became a new habitat, you know. So what he's doing actually, because so much out there, he does research about what's happening around that microbeads, what's happening around that plastic particles. They're starting a new life actually, and that is his special feat. You even create a new name for it. How do you say it?
The plastosphere.
That's a plastosphere, you know. So we have somebody here who really was even able to create a new name about it. So I'm super curious to have you here and to hear more about it.
Thank you.
Thank you to have you here.
Thank you.
Welcome. And we have another guest here from the Philippines.
Hello.
I'm so happy. Mercy.
Hey.
I just hope I pronounce it well. Ferrier.
Ferrer, yes.
I think it's Spanish actually, and my Spanish is bad.
Yes.
Okay. And I asked her, how should I present you? I loved it because she said, I'm a mother, I'm an activist, I'm a zero waste teacher and practitioner. So I loved it so much. That's Mercy. But besides that, she is a co-founder of that crazy, wonderful breakthrough from plastic movement. So happy to have you here. She is a project manager of the Zero Waste Cities project. Dumagute City? I read it right. Yes, and she's even a co-convener of the War on Plastic, what she called WOW. So I love it. So, sounds like Greenpeace slogan, so I really like it. So I'm really happy to have you all three here. And we will start with Manfred, the Greenpeace part. Should we try it in German maybe, or what do you think?
Ich fange mal in Deutsch an.
Yeah.
Und wenn irgendjemand was übersetzt haben möchte, Englisch kann ich es gerne machen. So if you want to have to translate something in English, just let me know, but I start in German. Dankeschön.
Uns Fragen stellen können. Also
ja.
ihr könnt zwischendurch, wenn ihr Fragen habt, wir machen das Ganze ganz easy, wenn Fragen kommen, wir beantworten die zwischendurch. If there are any questions, we will answer them between. And we have also our YouTube channel open, so people can also will ask us their questions, and then we will bring them here as well, because we want to share it, of course.
Ja, also ich zeige im Prinzip erstmal eine Reihe Fotos zu dem, was Viola schon erzählt hat, zu dem Brand Audit, was wir gemacht haben in 2017. Also das ist, das ist der Strand Freedom Island. Siehst du was?
Ja, alles gut.
Du kannst auch hier. Freedom Island ist eine Insel in der Manila Bay, Manila Bucht, nicht weit vom Flughafen, und die Meeresströmungen sind da so gestaltet, dass so ab Sommer das ganze Plastikzeugs, was in der Bucht rumschwimmt, an dem Strand abgelagert wird. Und dann sieht es so aus. Das ist ein Vogelschutzgebiet. Und es ist wunderschön, wenn man da hinkommt, aber sobald man den Strand betritt, nicht mehr. Das ist der Pasig River in Manila, der halt eine Menge Schmutz schon mal mitbringt, und so sieht es dann in der Bucht aus. Das heißt, bei jedem Hochwasser wird neues Plastik am Strand abgelagert. Was wir gemacht haben, was Viola ja vorhin erzählt hat, wir haben den Strand gesäubert. Wir haben pro Tag immer nur, ich sag mal so, 200 Meter haben wir gar nicht geschafft pro Tag. Wir haben gerade mal 30 Meter geschafft, mit ungefähr 100 Leuten komplett sauber zu machen, weil es einfach zu viel ist. Das ist Carabao Island, right? This is Carabao Island. So that is an island, das ist eine Insel, die einfach nur aus Plastik besteht. Da hat sich inzwischen so viel Plastik angesammelt, dass das begehbar ist. Und das ist, wenn man da hinkommt, ein bisschen erschreckend. Und das ist das Zeug, wenn du da mal reingreifen kannst, sozusagen. Das ist das Zeug, was ziemlich viel von dem, was man da sieht, ausmacht. Das nennen die Filipinos Sachets. Nescafé sagt, wir bringen den Filipinos, was sie brauchen. Nämlich, sie brauchen kleine Tütchen und keine großen Gebinde. Und das ist quasi so eine Tagesration.
Dann kannst du ein bisschen weiter rübergehen.
Vielleicht ein bisschen in die Kamera. Genau.
Was? Ach, das ist
Da ist die Kamera.
So, und das wird überall verkauft in den Philippinen, und das ist ein großes Problem, weil das Abfallentsorgungssystem ist auf diese Art von Plastik nicht ausgerichtet. Was wir gemacht haben, ist, wir haben jedes einzelne Teil in die Hand genommen und geguckt, welche Marke steht da drauf, und haben es dann sortiert. Und rausgekommen ist dann, rausgekommen ist dann ein Clean-up und Brand Audit, was wir dann vorgestellt haben. Das ist quasi zu Beginn der Pressekonferenz, da sind die Säcke mit den einzelnen Firmenlogos drauf präsentiert. der größte Sack ist Nestle und der zweitgrößte ist dann Unilever gewesen. Was ich dann noch gemacht habe, ist, ich war 3 Wochen her, also das war 2017, da haben wir dieses erste Brand Audit gemacht, dann wurde das Brand Audit nochmal wiederholt im vergangenen Jahr. Also es geht immer so darum, ein bisschen rauszufinden, wer ist da der Hauptverschmutzer. Wir sind in diesem Jahr dann mit der Rainbow Warrior erstmal in Manila Bay gewesen und dann sind wir ein Stück rausgefahren in die Verde Island Passage. Das ist so das Gebiet mit der größten Artenvielfalt unter Wasser, was es so gibt global. The center of biodiversity, that's what they say. Da waren wir mit der Rainbow Warrior und sind dann immer mit dem Schlauchboot und ein paar Taucher rausgefahren und haben dann unter Wasser dokumentiert. Und dieses Foto habt ihr vielleicht auch schon gesehen, das ist dabei rausgekommen, Noel hat es geschossen, also eine Krabbe gefangen in einem Plastikbecher. Und das drückt es eigentlich wunderbar aus, was das Problem darstellt. Es ist einfach, dieses Plastikzeug ist überall und die Tierwelt kann da natürlich nicht mit umgehen. Dann findet man in den Korallen auch eine Nescafé-Tüte oder auch eine Cola-Flasche oder noch eine Maggi-Tüte und so weiter. Also das, was wir machen wollen, ist einfach zu sagen, wer ist der Hauptverschmutzer, und wenn wir den identifiziert haben, adressieren wir den mit unseren Forderungen. Die Forderungen sind einfach zu sagen, okay, Single-Use-Plastik, also Wegwerfplastik ist nicht adäquat. Wir wollen andere Lösungen, wir wollen andere Verteilsysteme. Das machen wir zusammen nicht allein als Greenpeace, sondern eben mit der Koalition, zu der auch Mercy gehört oder die sie auch gegründet hat, Break Free from Plastic Coalition. And I would like to ask you to give us a few sentences. What is this about the Break Free from Plastic Coalition and how you see the problem in the Philippines? So, also ich bitte Mercy einfach uns ein bisschen was zu erzählen aus ihrer Heimat.
Yeah, maybe you come over here. I think it's good with the camera. If there are some other questions, please feel free. Caro, just wait for us, and then we will do something.
Hi, good
So
evening.
The stage is yours. Thank you.
Hi, good evening, everyone. This time it's English.
Yes.
All right. I am one of the co-founders of Break Free from Plastic movement. It's an international, global movement that we founded in 2016 in Manila. Not in Manila, but in the southern part of Manila, which is still part of the biggest island. And it is composed of, it was founded by groups from China, from India, from the Philippines, from the United States, from Europe. So it's really a global movement. This was born out of the initiatives of different countries and organizations in that countries that are working on zero waste work, which means sustainable living and alternative lifestyle. So we have banded together and said that there is a need for us to address this problematic single-use plastics. This actually here are all Nestle. And if you see the monster this morning, a part of it are all Nestle products and Unilever products. So we have, banded together as individuals and organizations. And the founding organizations are the following: Global Alliance for Incinerator Alternatives. This is a global organization that is working on saying no to incineration, meaning burning of waste, because it's even worse if you burn the waste. This is also co-founded by the China Zero Waste Alliance, and now we have more and more organizations. Just 2 days ago, our colleagues from Vietnam did their very first zero waste training, and they founded the Zero Waste Alliance in Vietnam. Actually, this is a big thing because years ago, there's no active groups in Vietnam that are working on cost-oriented groups. But this is a very good example that we are really working hard in this part of the world, in that part of the world, in addressing toxic pollution, plastic pollution for that matter. So I just want to say something as a backgrounder. Gaia, the Global Alliance for Incinerator Alternatives, recently launched a report, and this is a report from the Philippines. And the title of the report is Plastics Exposed, using the waste assessment and brand audit to know what is it that is causing the pollution in my country, the Philippines, and elsewhere in the Southeast Asia region. And one of the findings is more than 50% of all unrecyclable residual waste discarded in the Philippines is branded waste. You take note, branded waste. And only 10 companies are responsible for the 60% of all branded waste in the study sites that we have done. So if you can download that, we can actually provide a link later. It's a very good, very scientific study that was done by my colleagues in Gaia. It was released, I think, just last month.
Yeah.
And you will get more information and how we dealt and how the study was done by our communities in different parts of the Philippines. So I think it's just a teaser because it's really, I mean, I'm privileged to be here and fortunate to be here. This morning I told the live streaming that it's so important to send a message, not only to Germany, to Europe for that matter, but to the whole world, that we are doing our best through zero waste systems in the Philippines, in Malaysia, in Indonesia. But 20% or more of it are the residual, branded, non-recyclable, non-manageable waste. And that's why we're part of this. There's no more excuse for Unilever, for Nestle. And I just want to say for the last thing that we are, the misinformation that these companies are saying. Just a week ago, I read the Unilever press release. Yeah, there you go. The number one in the Philippines out of the studies that we did is Nestle. One. Number two is Unilever. Number three is Procter & Gamble, and I might be wrong. Number four is Coca-Cola, I believe. And so there is these top 10 companies that are really polluting our country. So the misinformation is that inadequate waste management systems and human negligence are often cited as the main contributors of plastic waste. Half of the story. That's not full. The real story behind it. The real story is 60% are branded and are coming from these big companies. And that's why we're here, and that's why I am here. And so the other message that I want to send is there is need for the Western world to understand and really know what's happening in our world, kind of, part of our world, and bridge that gap and understanding and solidarity, because that's the most important thing, for you to understand what's happening in our part of the world, and you understanding and we understanding the kind of struggle that you have there. But one thing that is so clear to me is that you don't have sachets like this. You don't have this. It dawned on me when I reached Amsterdam, talking to Greenpeace Netherlands. I asked them, do you have something like this? No, they don't have. And you see, that's the injustice. That is always the line that I say, why do we have this? Is it because we're poorer countries? I don't think so. Do we have alternatives? Yes, we have alternatives. So why the hell we have all these kind of sachets? Sorry for the word, or for the term. So I think I'd like to stop there. It's just a little bit of an backgrounder, where I come from and what's the message and the way that we work. So tomorrow I'll be explaining the kind of work that we do in the communities. Thank you.
So I know it was in English, so maybe not for everybody so easy, but no. Sorry if you just come. Please.
It's not a question. I'm from Bulgaria, and these things are very popular in Southeast Europe.
Okay.
And the companies, they're making so much advertisement, and not of the real coffee, but of this. The name of it is 3-in-1, and
We
this
have
is
it.
coffee, sugar, and
We have it all.
yeah, it's so popular, and the people love it.
Because it's being pushed.
But
Because
these are also poor countries.
yes, yes.
And I don't know why the big companies, they have these strategies in the poor countries.
There's
Not
one thing.
here.
One thing I learned today, I mean, if you work in a one-day thing, how do you say that if you just get money for one day? Tageslöhner, do you remember that?
Day money? Daily wages.
Daily wages, you know.
yeah.
So the thing is, actually, if you're working in these countries, you don't have a full-time contract like it's common in Europe. So you just get money for one day. You're working for one day, get money for one day, and hopes the next day you have another job. That means you got out in the evening with money for one day. So what you do for the next day, you buy the food for one day because you don't have more money. That means you buy one milk for one portion, you buy one coffee, you buy one bread. So, and the thing is, in the end, you'll end up with this thing in this plastic. Not just that you have more waste, it also costs much more money. You know, if you buy it like this, so you have to buy 7 of them, and they're much more expensive if you would buy a big one. But the company's making money out of it. You know, actually, what I hear today, you need to be rich to be poor. You know, they even make money out of this as well, and that's another thing. It's also such an
So, thank you for that information. In 2 months' time, we are coming out with another report, more on the economics of it, because we really want to say that they're getting money from the poor people actually, and pushing them, and with all the advertisement, there's as if there's no other option in the Philippines, or for that matter in Indonesia. But we have alternatives. And the one that we really want to push is the delivery system. Because some years ago, there is a proper delivery system. We don't have this sachet. If you want to buy a small, cup of coffee, you can buy it, but then you have to bring your cup and everything. So we can actually get that from small shops that was shown by our colleague here, the small stores that we have in the Philippines, because we have that before. But then we don't have it anymore because of all this small packaging. And it's all being thrown out. Just a throwaway thing. Okay. All right. Thank you.
Ja, ich bin auch schon sehr gespannt auf morgen, weil die Filipinos, muss man sagen, also nicht nur Gaia, die Organisation, für die Mercy arbeitet, Mother Earth Foundation, you have their Zero Waste groups.
Yes,
so there are so many initiatives in your country, and even in Manila, in this big Moloch Manila, who try to live without any waste. So it's amazing. So man darf sehr gespannt sein, was da morgen erzählt wird. Ich würde jetzt gerne ein anderes Land vorstellen, nämlich Malaysia. Das sieht so aus. Also auch nicht viel anders. Die Kollegen von Greenpeace Malaysia haben vor ein paar Monaten diesen Report rausgebracht, The Recycling Myth. Der ging auch ganz gut durch die Presse, weil es stellte sich raus, dass in Malaysia seit ungefähr einem halben Jahr Unmengen von Plastikmüll auftauchen, lose in Bergen oder gepresst in Ballen, und dass darunter auch eine Menge deutscher Müll ist. Das ist übrigens Heng, der Campaigner im Büro in Kuala Lumpur, der hat diesen Report maßgeblich mitgeschrieben, und ich war jetzt mit ihm unterwegs und bin 3 Tage lang durch diese Plastikberge gekrabbelt, und man greift so rein und findet plötzlich Frosch zum Beispiel oder Capri-Sonne. Und was mir nicht so klar war, ist, Capri-Sonne mit Strohhalm ist ja offensichtlich schon mal benutzt worden, das heißt, das ist Haushaltsmüll. Und wie kann es sein, dass Haushaltsmüll aus Deutschland in Malaysia landet? Das heißt, der ist schon irgendwann mal im gelben Sack gewesen oder in der gelben Tonne. Bitte? Ist das aus Deutschland? Naja, wenn da Kirsche draufsteht und produziert in der deutschen Fabrik, dann könnte es sein, dass es nicht aus Deutschland kommt. Aber wenn du ballenweise Müll mit deutscher Aufschrift findest, dann ist es sehr wahrscheinlich, dass er aus Deutschland kommt. Und an der Stelle, da wo dieser hohe Berg ist, daneben liegen 50 Ballen, immer 1 Kubikmeter Plastikmüll mit deutschem Haushaltsmüll. Daneben liegen nochmal 10, 20 Ballen mit vorsortierten Polyethylenfolien. Ne? Die kannst du recyceln, das ist überhaupt kein Problem. Aber dieses Zeugs kannst du eigentlich nicht recyceln. Da das aber eine Mischung ist aus Haushaltsmüll, wird er dort nach Malaysia exportiert Nach China darf er nicht mehr exportiert werden, weil China hat gesagt vom Jahr, wir wollen das Zeug nicht mehr haben. Jetzt funktioniert es so, dass es nach Malaysia geht oder nach Indonesien oder nach Thailand. Das sind jetzt die Länder, die unseren Müll sozusagen sauber machen und vorsortieren. Und dann wird das, was noch verwertbar ist, geschmolzen und gepresst zu Pellets und dann nach China verfrachtet, um dort als Rohstoff für die Plastikproduktion genutzt zu werden. Weil das nimmt China gerne an, das gereinigte, vorverarbeitete Rohstoffe. Das, was China nicht gebrauchen kann, bleibt dann da liegen in Malaysia auf diesen Bergen. Manchmal wird es dann noch tagsüber irgendwo hingekarrt mit LKWs und nachts angezündet, dann kokelt das so vor sich hin. Und da gab es dann irgendwie einen Aufschrei von den Anwohnern, logischerweise, weil die hatten enorme Atemwegsbeschwerden und ansteigende Krankheitszahlen und so weiter. Und jetzt ist es dann glücklicherweise zumindest teilweise gestoppt worden. Das Zeug liegt aber wirklich noch in großen Mengen darum. Wir durften dann, wir durften dann auch an einer Razzia teilnehmen. Also in Malaysia ist es inzwischen so, dass die Regierung hat auch keinen Bock mehr darauf. Die sagt, wir wollen euer Müll nicht mehr haben. Und die haben auch keine Lust auf diese chinesischen Unternehmer, die quasi auf malaysischem Boden mit chinesischen Arbeitern unseren Plastikmüll vorsortieren. Deswegen machen sie auch von Regierungsseite inzwischen ziemlich Dampf. Die hatten dann australische Medien eingeladen und auch Greenpeace. Und das habe ich auch noch nicht erlebt, dass Greenpeace von den Behörden eingeladen wird, an einer Razzia teilzunehmen. Das fand ich echt cool, da durften wir dabei sein. Und das war schon besonders. Da war natürlich niemand mehr da, als wir da eintrafen mit Blaulicht und so weiter, weil wir waren schon vorher, ich weiß nicht, wir wurden erstmal zum Frühstück eingeladen, dann gab es noch ein Briefing. Und bis wir dann mit dem ganzen Tross an Medien und Polizei und so vor Ort waren, war da natürlich niemand mehr. Aber ja, war spannend. Zu dem Thema wird Greenpeace Deutschland sehr wahrscheinlich weiterarbeiten, zumindest Viola und ich arbeiten sehr stark daran, dass wir da noch was tun dürfen, weil wir finden, das Zeug hat da nichts zu suchen und es muss eigentlich zurückkommen. Mal sehen, wie wir das machen. Jetzt noch ganz kurz zu dem, was wir hier auf dem Rhein machen, aber erstmal mache ich einen Ausflug in die Antarktis. Da haben wir nämlich dasselbe gemacht. Mit der Arctic Sunrise, da durfte ich leider nicht mit, oder auch nicht. Das ist schade. Ich hoffe, dass wir das irgendwann nochmal nachholen können. Kollegin Sandra war da und hat Proben genommen. Wir haben Schneeproben genommen und wir haben Wasserproben genommen. Die Schneeproben, das hatten wir vorher auch schon mal gemacht, die haben wir untersucht nicht auf Mikroplastik, sondern auf persistente Chemikalien. Fluorierte Chemikalien zum Beispiel, die finden sich global verteilt im Schnee. Kann man wunderbar nachweisen, dass das Zeug einfach langlebig ist und überall auftaucht. Wir haben aber auch Mikroplastikproben genommen. Da sind einfach nochmal ein bisschen die Probenahmestellen in der Antarktis aufgezeichnet, wo wir überall gewesen sind. Was haben wir da gefunden? Wir haben 8 Proben genommen. Das ist mühsam, die zu untersuchen. 8 klingt jetzt nicht besonders viel, aber 8 Proben zu untersuchen dauert schon auch mindestens 8 Tage, wenn nicht mehr. Die Konzentration, also wir haben eigentlich in jeder Probe eine Faser gefunden. So, ne? Also ausgerechnet bedeutet das dann 0,8 bis 5,6 Fasern pro Liter. Das ist für die Antarktis ganz schön viel. So wahnsinnig viel mehr finden wir hier auch nicht, wenn man das auf einen Liter umrechnet. Das hat uns ziemlich verwundert. Was wir dann machen ist, das könnt ihr dann auch im Labor, oder habt ihr ja schon gesehen heute, viele von euch waren ja schon da. Das heißt, wir nehmen die Proben mit dem Manta-Troll. Unten links, das ist die Arctic Sunrise mit dem Manta, oben rechts ist die Beluga mit dem Manta, wie wir es heute auch vorgeführt haben. Und alles das, was größer ist als 300 Mikrometer, bleibt in dem Sieb hängen. Das werden wir dann ins Labor geben. Und dann sitzt da eine arme Person, die dann stundenlang ins Mikroskop schauen muss. Heute war es Lena. Das ist auf der Ostsee letztes Jahr, das ist Alex, die sich da auch stundenlang mit vergnügt hat. Das ist eine wahnsinnig aufwendige Arbeit und es ist ganz toll, Lena, dass du das. Und was wir dann da sehen, ist Mikroplastik ganz groß, wenn man es auf dem Bildschirm macht. Ne? Unten links, das ist so ein Mikro. Wir werden ja flussaufwärts fahren. Nicht weit von hier in Wesseling ist eine Fabrik, habe ich mir sagen lassen, die solche Pellets herstellt. Und ich denke mal, das ist the real science now.
Maybe I just interrupt. So
yeah,
thank
okay.
you. Are there any further Das war jetzt viel auf einmal, 3 verschiedene Themen, deswegen frage ich mal.
Achso, ja, der Frage.
Weil es ja immer heißt, Frosch produziert Verpackung aus 100% recyceltem
Ja.
Plastik. Das heißt, man kann es auch nicht mehr guten Gewissens kaufen.
Naja, da kann Frosch jetzt auch nichts dafür, dass diese Tüte da in Malaysia landet.
Ja.
Ne, das ist eher die Frage an den grünen Punkt. Ne? Also das grüne Punktsystem funktioniert ja so, das duale System, Deutschland heißt es DSD, funktioniert ja so, dass wir schön unseren Plastikmüll trennen, manche waschen den dann noch und packen den schön in den gelben Sack. Und dann ist das ja schon bezahlt worden, das Recycling im Prinzip. Ne? Deswegen gibt es ja den grünen Punkt und deswegen gibt es das duale System. Das heißt, eigentlich sind die Kosten für das Einsammeln und so bezahlt worden und dann gehen wir natürlich davon aus, dass die Froschtüte ins Recycling geht. Nun ist es aber so, dass diese Anlagen das sortieren, in Ballen pressen und dann irgendjemand auf die Idee kommt, das doch noch zu verkaufen. Da kann Frosch dann auch nicht so viel dafür.
Und warum passiert das überhaupt?
Bitte? Warum das passiert?
Ich denke immer so gerne an die Supermärkte zurück. Ne? Irgendwann haben die angefangen, okay, wir stellen jetzt hier für unsere Kundschaft Plastik, Papier, werden bereit, damit die nicht so viel Scheiß nach Hause nehmen müssen. Und ich weiß gar nicht, wie die das entsorgen oder ob die das dann direkt zurückführen oder dann auch dann das Feedback direkt an die Firmen geben und sagen, ihr macht eigentlich zu viel, wir kommen da gar nicht, wir werden gar nicht mehr Herr der Lage. So stelle ich mir das eigentlich nicht nur für den Supermarkt vor, sondern für ein ganzes Land. Warum
Ja, genau, so stelle ich mir das auch vor.
Ja, das verstehe ich überhaupt nicht.
So stelle ich mir das auch vor. Ich hatte auch letztens die Möglichkeit, mit so einem Staatssekretär von Nordrhein-Westfalen zu sprechen. Und der meint, ja klar, wir finden das auch scheiße. Also jeder findet das doof. Ne? Aber es passiert nichts. Also deswegen müssen wir irgendwas tun.
Aber ist die Lobby denn so stark, die dahinter steht? Also von den Herstellern? Oder?
Also ich glaube, dass es verschiedene Faktoren sind. Es gibt eine starke Lobby sicherlich. Ich glaube, das Hauptproblem ist, dadurch, dass China gesagt hat, wir wollen euren Scheiß nicht mehr haben, sozusagen, türmen sich schon Berge auf. Deutschland ist eigentlich im Vergleich zu anderen Ländern steht es noch ganz gut da, weil wir so viele Verbrennungsanlagen haben mit einer relativ guten Filtration, ne, mit einer relativ guten Rauchgasreinigung. Das heißt, hier geht noch viel in die Verbrennung und das kann, also wir finden das natürlich nicht Sinn der Sache, dass man Plastik einmal benutzt und dann verbrennt man es, sondern Plastik muss so hergestellt sein, dass es wiederverwendbar ist und dann recycelt werden kann. Dennoch, das Verbrennen ist eine Möglichkeit. Für UK, also England zum Beispiel, ist es das nicht. Da türmen sich noch viel, viel mehr. Und da sind die Ströme, das heißt, die stehen auch unter einem ganz anderen Druck. Da sind die Ströme sehr viel größer, da geht ganz viel nach Asien, aber jetzt haben sie festgestellt, ganz viel geht auch in die Türkei. Da gibt es inzwischen so eine Industrie, die das Zeugs dann verwertet, also sortiert und verwertet und so weiter. Und warum das so ist, ja, offenbar ist es immer noch genug Zeugs in dieser Mischung drin, was man aussortieren und verwerten kann. Was nahe liegt, finde ich so, oder was man sich noch ganz gut erklären kann, ist, wenn das jetzt Folien sind, also reine Polyethylenfolien, die alle gleich sind. Und wenn man die dann in Ballen presst, dann kann man sagen, okay, das ist Ausgangsstoff für eine neue Plastikproduktion, muss einmal eingeschmolzen werden, dann kann man es wieder benutzen. Das leuchtet ja noch halbwegs ein. Aber warum man diesen Haushaltsmüll, also diese Mischung da jetzt noch hin verfrachtet, leuchtet eigentlich niemand ein. Aber es ist immer noch ein Geschäft.
Ich wollte noch sagen, dieses Wort Recycling ist ja auch ein utopisches Wort, weil eigentlich muss man Downcycling sagen, weil du kannst Plastik vielleicht ein- oder zweimal recyceln und dann ist das so brüchig, dann kannst du es nicht mehr verwenden.
Ja,
dann kannst du es nur verbrennen oder irgendwo bunkern, der Tunnel oder sowas, weil das ist halt das große Problem dabei.
So. Wir müssen vielleicht noch eine Bresche schlagen für den grünen Punkt. Ne? Also ich muss dazu sagen, ich lebe auf Zero Waste und finde, dass das eigentlich der einzige Weg ist, nämlich wegzukommen vom Single Use und nicht halt von Single Use Plastik auf Single Use Papier umsteigen oder so. Und das Ganze muss halt komplett bedacht werden. Aber natürlich ist es wichtig, dass wir Müll trennen, denn das ist die einzige Möglichkeit von dem, was jetzt schon da ist, das wieder einer sinnvollen Nutzung zuzuführen. Also es soll jetzt nicht heißen, trennt euren Müll nicht mehr und verbrennt ihn zu Hause oder schmeißt ihn weg. Natürlich ist es wichtig, dass man sich damit wirklich auseinandersetzt, wenn halt schon Müll anfällt, wenn Plastikmüll anfällt, dass er wirklich auseinandergenommen wird. Wenn man einen Joghurtbecher hat, dass der Deckel abgenommen wird, dass das Papier, was zum Rum ist, vielleicht in den Papiermüll kommt und dann der Becher von dem Deckel getrennt in den Müll kommt. Denn je weiter es getrennt ist, je sauber es ist, desto besser funktioniert wirklich das Recyceln, das echte Recyceln und überhaupt die Möglichkeit für das Recyceln zu geben. Also überhaupt diese Awareness zu kriegen und mit den Leuten darüber zu reden, ist total wichtig, das auch selber zu tun. Das sollte jetzt nur heißen, also nicht, dass ihr aufhört
Genau,
irgendwie, ne?
weiter trennen.
Genau, weiter, das ist eigentlich die Grundlage dafür. Das Problem ist eher, dass das nicht der Fall ist, denn solche Verpackungen, was ihr hier seht, ne? Also was wir gerade gehabt haben, diese Capri-Sonne Kirsch, das ist nicht zu recyceln, weil das Verbund ist, da ist aller möglicher Kram zusammen. Wenn dieser Strohhalm alleine wäre, kann ich den recyceln, aber wenn die Sachen weiterhin zusammenhängen, sind die nicht zu recyceln und dann entstehen halt diese Ballen, die dann halt, wo ein bisschen was drin ist und die werden dann halt irgendwie verkauft. Das ist halt das Wichtige.
Frage noch, aber inwiefern ist denn der Gründepunkt verpflichtend für die Hersteller, um drauf zu machen auf die Verpackung? Weil ich habe jetzt auch zum Beispiel verschiedene Verpackungen zu Hause und die sehen sehr ähnlich aus. Ja, auf dem einen grüner Punkt und dem anderen halt nicht. Kann man sich dann darauf verlassen, dass dann da, wo kein grüner Punkt drauf ist, dann auch kein grüner Punkt drauf sein wird?
Ne, sag mal, also ich finde, es müsste überall einer drauf sein.
Ja,
ne? Also, weil du von der Zollfrage kommst.
Ja.
Es gibt ja das neue Verpackungsgesetz in Deutschland, was jetzt in Kraft getreten ist in diesem Jahr, was eigentlich besagt, dass 58% der Verpackungen, die in den Markt kommen, recycelt werden müssten. Das ist die Quote. Jetzt kommt aber, je nachdem, wie man das rechnet, gab es halt auch so Recherchen, dass man vielleicht so auf 5,6% kommt in Deutschland, die wir wirklich haben, die recycelt werden, weil halt zum Beispiel solche Müllexporte rausgerechnet werden, wo halt nicht belegt werden muss, wo die Sachen hingegangen sind. Das Problem ist halt wirklich hierbei, wenn man sich diese Produkte anguckt, dass es halt nicht eine direkte Verantwortung ist. Wenn ich ein Paket verpacke, es dir als Konsumentin gebe und am Ende was übrig bleibt, nehme ich es nicht direkt zurück, um es weiterzugeben, sondern ich bezahle einen Obolus. Ich bezahle sozusagen eine Art Steuer auf die Menge an Verpackung, die ich in den Umlauf bringe. Und dann wird dieses duale System dafür bezahlt, sich um den Rücklauf zu kümmern. Das heißt, es ist nie die direkte Verantwortung der Firmen. Und genau das muss angeprangert werden, weil wir brauchen eine direkte Verantwortung dafür und deswegen liebe ich ja dieses Projekt, weil es halt einzelne Firmen, wir haben es gehört, es sind halt 10 Firmen, die für 60% dieses Mülls verantwortlich sind. Es ist gebrandet, die kann man verantwortlich machen, die können sich nicht verstecken, denn die wollen ja, dass man es sieht auf der Verpackung. Dann lasst es uns auch sehen und lasst es ihnen zurückbringen. Ja? Das ist halt das große Problem bei uns beim Proben. Ja, haben wir vielleicht irgendwelche Fragen noch aus dem Netz? Ist alles gut. Okay. Dann, wenn jetzt keine konkreten sind, dann Eric. Do you want to come? Finally. The stage is yours.
Good evening, and a huge thanks to Greenpeace for inviting me to participate on this cruise. It's a really valuable opportunity for myself, my partner and collaborator Linda Amaral-Zeller, and the group of scientists that we're working with at NEOS and Utrecht University. I'm going to talk a little bit about my particular interest, which is the interaction between organisms, between life and plastic in aquatic systems. And that's a term called the plastosphere. I'll explain a little bit more about that later. And this has been a huge sort of collaborative effort. I consider it a collaboration. And obviously I couldn't have done any of this without a lot of help. I've only named here the people that have so far helped me on the boat. That doesn't include any of the Greenpeace people in the Netherlands or Germany who have helped me in other logistical ways and made me feel very comfortable and welcome. So thank you. Also, I apologize for speaking in English. It seems to be, the Anglophones seem to just basically expect other people to understand their language, and I apologize for that, but I wouldn't get very far in German. My interest overall is in what's the fate of plastic in the ocean. I'm mostly an oceanographer. This is my first river expedition. But we want to know what happens once the plastic comes from land, which is where we think most of it comes from. We obviously know it fragments, but I'm a microbial ecologist, so my particular interest is almost as soon as it gets in the water, it starts to be covered with a little biofilm of microbes. They might influence its density, they might make it sink more or float more. They might make it taste or smell good to the fish and other things that eat it. Some of those microbes, so PMD is a abbreviation for plastic marine debris, some of those microbes that attach to the plastic might be potentially harmful. They might be able to cause diseases in animals or humans. They might carry algae that can cause toxic outbreaks in shellfish that eat them, like red tides. And then ultimately, if those get eaten by things, and we eat things like shellfish, could that get passed on to humans on your dinner plate? And then finally, of course, I'm interested in what's the ultimate long-term fate of plastic in the ocean. If we were to stop putting plastic in the ocean tomorrow, tonight, how long would it take the plastic that's remaining in the ocean to go away? A lot of times you hear that plastic is forever, it will never break down. That's not really true. It will break down, but it will take a long, long time, hundreds, thousands of years. So really the solution is to stop putting it in and let the ocean clean itself up. Also, I want to say, because please feel free to stop me if you don't understand something or you have a question. Don't wait till the end, because if you're like me, you'll forget the question by the end. Okay, let me go back to this first picture. So this is on the beluga, and there's a little system to put the manta net in the water. Have some of the collaborators in the back row there, and of course Manfred up front. The net's here on the deck right now, but what it looks like, this is from another cruise because I haven't gotten any. I've been busy on the boat, so I haven't gotten any pictures. This is basically what a manta net looks like. Manfred showed it as well. These wings keep it on the surface, and basically it's designed to skim the surface layer of the water and capture anything that floats. Because we know the width of the net, if we keep track of how far we tow it, we can then quantify that plastic and say how many particles of plastic are there per either square meter or by volume, by cubic meter. So that's some of the numbers I'm going to be presenting. Once the net comes on board, again, this is all oceanographic work. This is from a cruise we did from the Azores to Sicily last summer. Basically, you pick visible plastic out of it, you sieve it to separate the zooplankton, and then we pick it out and we put it in a tray. Most of the pieces, it was very interesting to see Manfred's presentation because near the land you can tell where it comes from. I think this sort of figuring out the inventory of who's responsible for it, it's great. We can't do that usually in the ocean. Usually in the ocean it's broken into such small pieces that I can't really identify who it came from or where it came from. And then we also tend to measure the plankton, the biomass, because we want to know, that versus that's available to fishes. Well, the first thing I learned working on rivers is it's a heck of a lot harder. There's all this stuff, like in the open ocean we basically have plankton and plastic, and it's pretty easy to tell the two apart, usually, unless you get a lot of jellies. Here on the river, every toe pretty much looks like that. It's loaded with leaves and grass and wood with tiny little pieces of plastic mixed in there. So it takes many sets of younger eyes than mine, many hours to pick out each of those pieces of plastic. And these guys are tireless, let me tell you. Okay. First thing, you're probably better educated about plastic than my average audience, but I always like to sort of set the record straight. The perception versus the reality of plastic in the ocean. So you hear about the Great Pacific Garbage Patch, and you see images like this or this. Let me tell you, I've sailed for 30 years on the oceans. I've been in most of the major oceans. There's nothing out in the oceans that looks like this. And there's really nothing out in the oceans that look like this. Maybe near shore, maybe near where a river comes out from a major city, but in the open ocean it doesn't look like that. You read things like this in the US press, twice the size of Texas, you can see it from space. No, none of that stuff is true. So that's the perception. This is the reality. So this is from one of our papers in 2014. This is the Great Pacific Garbage Patch. This particular day is the day that in my 30 years of oceanography, we saw the most plastic we've ever seen in 30 years. And that's what it looked like. It looked like beautiful blue ocean. If you look closely over the side of the boat, now you start to see little pieces of plastic. And when you tow a net through it, you see lots of pieces of plastic. So I'm not saying there's not a lot of plastic in the ocean. Do you occasionally see a large piece like this? Do you occasionally, yes. Do you occasionally see an area the size of this room with fishing nets and other things? Yes. But that's the exception. By far most of the plastic is these tiny, tiny little pieces. But the ocean is a really big place. So when you add up all that plastic, it's still a lot of plastic in the ocean. And going back, I want to just go back to this slide. thing about the fate is you've probably heard about the missing plastic, right? We know we're putting 10 million tons a year in. So I always like to use a reference point. We're producing, we just went over, as a global community, we're producing more than 300 million tons of plastic per year. Just put that in perspective, that's about 35 kilos for every man, woman, and child on the planet every year that we're producing. We know about 10 million tons a year is going into the ocean, but when we go out there and do surveys, people that have done it all over the world, we can't account for even 1 million tons. So we can't account for 10%, even 10% of 1 year's plastic. So the question is, where's it all going, right? So that's what I'm, and other colleagues trying to figure out, what's happening with plastic, where's it going? Okay, so it also can stay out there a long time. This is just an anecdotal example from, we had a cruise in January in the South Atlantic Gyre. So basically the South Atlantic garbage patch, if you want to call it that. And we pulled this on board one day. This is actually a meteorological buoy. These are buoys that the weather people put out. Yes, oceanographers do put plastic in the ocean on purpose. Hopefully it's a small amount, and hopefully we learn more about the ocean than the damage caused. Hopefully. I think we do. So this has a temperature probe and a GPS, so basically it follows the currents and the temperature and helps people predict current patterns and weather. So we picked this up, and it had a number on the top. We picked it up right here in 2019, January 15th. So I emailed a colleague who deploys these kind of things, and he looked at the number for me. He said it was deployed in 2004 off of Argentina. It drifted for basically 1.5 years, then it stopped transmitting, and we found it 14 years later, and it's been going around the ocean for 14 years, and you see it still looks pretty darn good. So that plastic's going to be out there a long time. Okay, my new backyard, since I moved to the Netherlands a year and a half ago, North Sea. So I'm here, I'm on the island of Texel. I want to learn a little bit more about my backyard. I haven't worked in the North Sea before. So there's some literature from Belgium and quite a bit from Germany, mostly coastal stuff. But the question is, of course, once I start studying that, where does it come from? Does it come across the Atlantic from America? Does it come from Africa up through the equatorial region? Well, of course, we know a lot of it comes from rivers, but we don't really know how much. So when I got the opportunity, when Greenpeace contacted NEOS and said, we'd like to invite a scientist on board, what a great opportunity to go all the way from the source, from where it comes out in the ocean to the source and be able to sample plastic the whole way. What do we know already? There have actually been some very good studies on plastic in the Rhine. This is mostly from a group in Switzerland. This is Mani et al. Paper in 2015, and they sampled all the way from Basel down to Rotterdam as well. And this plot over here shows, this is, what is this? This is number of pieces of plastic per 1,000 meters cubed. So 5,000, 10,000. And I'm concentrating, for this cruise, we're not doing, they're looking at these tiny little things called spherules, tiny particles that I'll talk a little bit about later, but those are very hard to pick out by eye. So we're talking with this cruise mostly about fragments and fibers, sort of like what I showed you on that tray from the ocean boat. And that's this blue line, that records what they found. They sampled in 2014, so 5 years ago. And along the river, what did they find? It was everywhere from very little to about a little over 6,000 particles per 1,000 meters cubed. So, what have we found so far? Well, that's these red stars here. So, a lot of difference. In some places, we're finding significantly less. So these correspond to very, very close to where they sampled. This is what we found. In some places, we found almost exactly what they found. In some places, we found less. But just south of Cologne, we actually found more than double what they found. So this just says, the river is a complicated system. It probably varies not just 5 years down the road, it probably varies day to day, month to month, as you have a rainfall. So it's a dynamic system. If you want to understand what's going on, you're going to have to monitor it more closely than once every 5 years. one thing that they talked about that I said is those microbeads. So this is a picture from their paper in 2015. These are ones that we picked out in almost the same place 5 years later. Similarly, these are all to the same scale, so exactly the same scale. You see we're seeing sort of their smaller ones, but we're not getting some of the big ones, we're not getting the colored ones. And obviously if those young eyes picked out these ones, they would have seen these if they were there. So again, a difference. Something I haven't seen, but Lena says she's seen before, is these little rectangular dots. I haven't seen these in the ocean. I don't see these in the ocean. I don't see these in the ocean. So somehow they disappear before they get out to the open ocean. This is, sorry for the bad picture, but it was taken on my iPhone in bad light. This is the typical nurdle or pellet that you talk about, also to the same scale. And this is what I'm used to seeing in the ocean. So we're seeing a big variety of these different kinds of beads and different stuff than what we see in the ocean. So the river and the ocean are not exactly the same as far as the plastic. No big surprise, but something new for me. So Mani et al. Went back, published this year, sort of zeroing in on just the micro beads. And they looked at a section between Cologne and Duisburg where they thought most of it was probably coming from. And they monitored the plastic beads there. Again, the red stars, we only have 2 sites because we're only sampling once or twice a day. We only have 2 sites in there. And again, very different. Here we got a lot less than them. But here, south for me, rivers to me flow south. North of Cologne, they found almost none, and we found basically a sphere per meter cubed. So that would be 1,000 on that previous chart. So again, differences. We're seeing similar kinds of particles, but different numbers. So this is all very interesting to me. Okay, so you might ask, well, why are you doing that again? Someone's already done that, right? I've heard well, that's already been studied, the plastic in the Rhine. But we're trying to add to the existing knowledge with this collaboration with Greenpeace. For one thing, it's another time point 5 years later, and hopefully I've shown you that it's important, there are differences. We're also looking at a broader size range. They looked at basically things that you can see by eye or in a microscope. We're doing a number of things. We're filtering the water using peristaltic pump here onto a filter, so that's a 47 millimeter filter, 2 micron pore size. So anything bigger than 2 micrometers, 2 millionths of a meter, is going to get stuck on there. Then we take that back to the lab and we look at it with a very fancy microscope that can also use a spectrometer, use light waves to figure out what kind of plastic it is. So hopefully we can tell how many tiny pieces that we couldn't see by eye and what kind of plastics there. Sort of going to the next size range down. With colleagues at the University of Utrecht who are developing a new method, we're trying to even go to the nanoplastics. You might have heard of nanoplastic. It's sort of the latest thing. Essentially, the smaller the pieces get, the more difficult it is to study. So we know pretty much about the net stuff. We don't know too much about this. We're starting to work on this, and nanoplastic is brand new. Why do we care about nanoplastic? Well, nanoplastic, unfortunately, is small enough that it can get into your tissues. Like, we're all eating plastic every day. We're all inhaling plastic every day. You can't get away from it. Your clothes, curtains, fabrics, everything. But most of it passes through our body. It doesn't get into the cells. The problem with nanoplastics is they go right through into your tissues. And we have no idea. There's been some evidence that they can cause irritation, but we really don't have any idea what they do. So there's more and more interest in figuring out where the nanoplastics are. Oh, sorry. Yeah.
Are there some questions so far? Irgendwelche Fragen oder Verständnisfragen?
Sorry, I tend to speak fast when I get excited. So
slow down. But it is exciting.
It's amazing to follow. You're just, you know, it's in English. Wenn irgendwer Fragen hat, gerade Verständnisfragen, hau du rein. They love you. Go on.
Seriously. Okay, so my major focus, our major focus, I should say also that, by the way, my partner and collaborator, she's the head of the lab. I'm just the assistant. So it's I happen to be here. She sent me because she has more other things to do. Okay. So, and she's also the one who invented the term the plastosphere, which caught on. So why did we come up with that term? This is an expanded polystyrene buoy that I found many years ago on a trip between Bermuda and Woods Hole, Massachusetts, where I worked for many years. And we sort of said, oh, we're trying to come up with, you know, a catchy term for microbes on plastic. And here you can see everything from algae to sponges to barnacles to, you know, to macroalgae. Who knows how long it's been out there? And we sort of thought, okay, well, just like the biosphere is the thin layer of life on the outside of our planet, we're part of the biosphere. Well, plastosphere is the thin layer of life on the outside of every piece of plastic in an aquatic environment. So that's how we came up with that. So how do we study that? And why is it important? Well, we know that plastic of different sizes enter the food web. You can have everything from little tiny 500, half a millimeter pieces being taken up by the little plankton, little copepods. You can have, this is sort of what we normally find in our nets. That can be eaten by, you know, amphipods, lanternfish, mackerel. And then you have these big ghost nets and bigger pieces. Those can be eaten by sharks, marine mammals, sea turtles, things like that. In addition, of course, if one of these guys eats 10 of these, and then one of these guys eats 10 of these, and then one of these guys eats 10 of these, and so on and so forth, by the time you get up to something we're going to eat like that, there could be a lot of pieces of plastic. Okay, but animals aren't stupid. Why do they eat all this plastic? Why do the birds and the fish and the turtles and everything eat plastic? I'll have you hold that thought for a minute. Some of them are stupid. Some of them just eat whatever's in front of them, especially filter feeders, you know, things that just take particles out of the ocean. They can't, some of them can discriminate, but a lot can't. Well, it turns out that this is, by the way, this is a scanning electron micrograph of a piece of plastic that I put in the ocean off the east coast of the USA. That's after 1 week. Brand new piece of plastic, clean plastic, like a piece of milk jug. Each one of these little things is an individual cell, a phytoplankton cell, like a miniature plant that creates the food, bottom of the food chain in the oceans. They're completely covering this plastic after 1 week. Well, this Savoca, these guys came out with this paper that they basically figured out that these kind of diatoms can emit a chemical that seabirds, believe it or not, actually, a lot of the open seabirds, they find food by their nose. They're olfactory smellers. So first they circle and they smell something, then they go down and they look at it visually. So the first cue is smell. Now, have you ever picked up, this is going to be the participatory part of the lecture. How many people have picked up something out of the water, the river or anywhere else, and smelled it? It's got kind of that slimy feel, and you smell it, it smells like life, right? It smells like algae, it smells like fish, it smells like plankton. It smells like fish and plankton to them too. And we think that might be one reason why they're eating it. And of course, another big question is, we know that, you know, there are toxic chemicals that can absorb plastic as well. If the microbes make the things eat the plastic, what happens inside the gut of the fish or the bird? Does that toxin transfer to the animal or not? There's some evidence it does, but whether that actually impacts the animal, we don't really know. Okay, so again, this plastosphere, we look at it a variety of ways. We identify the plastic using that fancy spectrometer I told you about. We use electron microscopy. I already showed you that picture. The other, we culture things. We try to grow things so we can do experiments with them. And of course, we use DNA, you know, sort of like CSI. Is CSI a show in Germany, or do you have a similar show? No, right? You know, where they take the little, tiny little piece of hair and they put it into the thing, and 60 seconds later, aha! It was you! No, it doesn't work that way. So I already showed you electron micrographs. We'll go through that. Okay, DNA. Essentially, we take a little piece of plastic, the size of my fingernail, typical one, and we extract all of the DNA. We just take every bit of DNA off it, and it doesn't make sense, but we chop it up into little pieces, and then we sequence those little pieces. This machine can sequence 1 million pieces in one run, and then we put it all back together. We use fancy computer programs to basically put it back together, and we get this alignment of a certain gene. And for instance, this is, you know, killer whale, orca. We use it for microbes, and the reason we need to use it for microbes, if we go back here, a lot of microbes, you can't really identify them by how they look. They're not, don't have enough morphological features. They all look the same. They're little round things or little long things. So what we can do with that is we can actually identify them. And on a piece of plastic the size of my fingernail, there might be 1,000 different kinds of bacteria, not 1,000 individuals, 1,000 species. So really high diversity. What's particularly worrisome about that is that we've shown, and others have shown as well by that there's some evidence that there are harmful bacteria, including Vibrio. Now, Vibrio is a natural marine bacteria. It's everywhere. But some species of Vibrio cause diseases, including in humans. Cholera is caused by Vibrio cholera. It can also cause diseases in fishes, in crustaceans, in shellfishes, so a lot of the things we like to eat. And if it got into food, particularly like in an aquaculture system, what are the nets and the ropes and the buoys? A lot of aquaculture equipment is made from plastic. So if the Vibrio like to attach to plastic and it gets into an aquaculture area, it could be a significant problem. We don't have any hard evidence right now that plastic has ever caused this kind of thing, but the potential is there. And a colleague from Spain, Masso et al., they have shown that also harmful algal bloom species that cause red tides and can make mussels and other things inedible, they also occur on plastic. And in addition, bigger things can attach to plastic. These little crabs here, this is from a ghost net in the Atlantic, those little crabs there are called Columbus crabs, and they normally, their natural habitat is sargassum, the brown algae that floats around. Well, now they're starting to jump onto plastic. Why does that matter? Well, because sargassum has a limited distribution. It's organic, it dies, it sinks. Plastic can circulate, as I showed you with that buoy, for decades, and so has the potential to transfer species to other areas. Some people have asked me, well, isn't that a good thing? You know, you're putting the plastic out there, you're increasing the biodiversity. No, literally, I've had this asked of me. And the point is, yes, you're increasing the biodiversity, but it's not necessarily biodiversity that should be there. And it could come at the expense of the natural community. So it's not, we shouldn't do things that we don't understand yet. Okay, I want to end, I always like to end with a positive note. Because I was a professor for many years, and sometimes my young university students would just so, what's the point? We've already, you old people have already ruined the world. What can we can't make a difference. Well, we can make a difference, and that's what I think you guys are really good at. I like to show them, these are two real examples from research that the organization I used to work for in the United States did. This is oil tar balls. So oil spills in the ocean. The lightweight molecules evaporate off, and you end up with little, I don't know if you've ever seen them on beaches, little tar balls. It's a residual. Well, we started measuring them in 1980, and you see there's a lot of variation. This is over years from 1980 to 1993. So in 1982, the Marine Pollution Act came out, which made it illegal for oil tankers to rinse their tanks and then pump the water out into the ocean. And we see, there's a lot of, it's messy, but there is a real decrease. And anecdotally, I can tell you, I used to have students do projects with tar balls, and at the end, here I had to say, well, you can't really do a tar ball project because we might not find enough tar balls. So that's a good thing. But same with plastic pellets. There are still a lot of plastic pellets in aquatic systems, as Viola just found today on the Rhine, and we've seen as well. But in the open Atlantic, again, this is from our data, we see a statistically significant decrease from 1985 to 2010. Part of that, we think, there's no proof, but in 1991, because of public pressure, some of the plastic companies, some of the coalitions of plastic companies, I think in the United States mostly, got together and said, okay, we're going to have this thing called clean sweep. And when we transfer plastic pellets from the factory to the truck, or the factory to the train, and the train to the boat, very simple. We'll just clean up anything that's spilled, that's obvious. And they didn't used to do that. They would just let it wash into the ocean. Obviously, they don't want it to go in the ocean. It's their product. It's worth money. But public pressure sort of made them say, well, okay, let's clean up our act. And again, a statistically significant decrease in the number of plastic particles. Not overall plastic, still a lot more plastic, but the actual pre-production dates has actually gone down. So the point here is that public opinion and public pressure can make a real difference. Sometimes you feel like, okay, me as one person can't do much, but it does, it works if you keep up the pressure. So I will end there and just thank everyone again. Thanks again to Greenpeace for this opportunity, and I'd be happy to answer any questions. Yes?
The last graph, might it be that the particles were getting smaller and smaller so that you couldn't measure it this way? Because it decreased, but that might be that the particles got smaller.
For the pellets, for this one?
Yes, yeah.
Oh, absolutely.
And more harmful for us.
Absolutely, and that's a great question. We think part of the reason that we can't find all the plastic, one theory is, of course, that it's sinking. Another theory is that it's breaking into such small pieces that we don't see it. And I think both of those things are happening. But this was actually looking at these guys. And all this is telling us is that somehow fewer of those were getting into the North Atlantic. And so I like to give credit to public pressure, because that's over a long time. That's over 50, 25 years, and it's a statistically real. But yes, absolutely, they're also breaking down. So even if we stop putting plastic in, it's going to continue to break down and fragment, but eventually, with that plastic will go away over a long time if we can stop putting it in. Yeah.
Have you ever read anything about microplastic in the water sea?
About what? Sorry.
Microplastic in the water sea.
I have not. I would be very curious if you know of any that exists. Again, I'm fairly new to the Northern Europe scene. I'm still trying to catch up with the literature. We're starting to. NEOS is right on the Wadden, so we're trying to start monitoring it there. And I know some researchers at NEOS have done a little bit of work there, but I don't think that I know of. There's no systematic measurements at this point. But yeah, it'd be very interesting, especially with all the mud flats that birds are feeding on and mussels and other things. Yeah. Yes.
Who is able to do researches on nanoplastic? Is it is it very difficult to?
It's very difficult. It's very difficult. As far as I know right now, there's only one research publication on nanoplastics in the ocean. It was by a French group, Terhal et al. The group that we are working with at Utrecht University is led by a chemist, and they have what we think is a new technique that will allow us to quantify that, which is very exciting. But yeah, it's very new. As I said, the smaller the particles get, the more difficult it is to study them, to basically to collect them and then to identify them. But yeah, so I see at this point there are very few laboratories in the world. A lot of people are trying to figure it out because we think it's important, but we don't know very much yet. Yeah, good question. Yes?
Do you know how small the particle has to be to enter our cells?
How small it has to be?
Yes.
I'm not an expert in that, but what I've heard is somewhere in sort of the less than 200 micrometer range. So basically, a tenth of a millimeter. No, wait, am I getting it wrong? Is that nanometers? No, I think it's below 100 micrometers is where we start to worry about it getting into tissues. Don't quote me on that. I can try to get back.
It's 100 nanometers.
Is it? What is it?
1 or 200 nanometers. It's not. Micrometers would be too big.
Yeah, no, it's nanometers.
Okay.
Yeah.
Okay. Nanometers, not micrometers. Yes.
If I'm zero waste and I don't eat fish or any of those products, how is there other ways that plastic can come into my system?
From your clothing, unless you use all cotton. From when you ride on the subway or the train and there's synthetic things around you and you're eating your sandwich. Not a lot. I don't think you should worry about it. I do eat fish, and I have not stopped eating fish. I think the benefits of fish still, to me, outweigh the unknown risk, which I think is a small risk at this point, of plastic in fish. I think they're far greater sources of contamination for me than eating fish. So at this point, I think we're at a point where we can still stop things before they. I like to be positive. Stop things before they get too bad. But we have to start acting now. We can't put it off for another 5 or 10 years. Did you have something?
Yes, I have to add because it's so crazy. As you know, maybe it's found in salt. If you just buy salt, sea salt.
Only sea salt, right?
Yes, sea salt it's already. So there it is, and water. Like if you say you're living zero waste, so you don't drink bottled water. Yes, but even in tap water it gets found now. It's groundwater, so even there it is. I mean, nothing compared with bottled water. So there was just a testing out there, I think a year old or so. They found nearly in every more than 100 pieces in one bottle of water, especially from the cap. So think about it's crazy. So if you ever want to talk to somebody about don't use plastic bottles anymore, I really love that to show them how much plastic is in it. It's a very good starter if you do that discussion and have it often. But even in normal water you found it in tap water, so it's just starting to become all over. It's really crazy.
But how how good is the filtration system in Germany because of drinking water which is coming out of the Wasser?
Yeah. The other thing is what we see already, like for fibers, for example, it's the same. As smaller it gets, as more complicated it gets, because we are not able with the filter systems we have in Kläranlagen.
Wastewater
I'm so sorry for my English earlier. So it's not able to get the stuff out of it, you know. They're not made for it often because it's very complicated, and we have already quite a high level in Europe and in Germany. But even then, especially fibers and other little pieces, it's just too much. You're not able to do it. If you have normal filter systems, just filters, they will be blocked. So there are different kinds of that you do, like little twisters and things like that. So there are a lot of ideas about and testing, but we have so much of that stuff coming into it that it's not able to get it out. And if it comes to measure how much of that microfibers and then plastics is even in the sediment, that's a totally different story. So it's really.
But I think you can minimize your intake, which is good. I think that's the goal, to minimize it where you can. Yes?
No, I'm sorry, my English is not so good. Are there any scientists or people to be able to engineer some filter system?
Yeah, I
for
think
the nanoparticles?
For the nanoplastic, it would be very, very difficult.
Are there any scientists around the world?
I think that might be an ultimate goal, but from what I know about nanoparticles, we're not really at a technology level where we can do it, but not on a commercial scale, not for the city of Cologne. Yeah. But I think something to always keep in mind with plastic and other contaminants is we have limited resources to address problems. So I think the important thing is to prioritize and figure out, what's the most right now. Where we can make the most impact with our resources, and we need to know more about nanoplastic. I think before we can invest too much in trying to actually get it out of systems. Yeah, I mean nanoparticles are natural. Nanoparticles have always been out there in the environment, and they can get into your tissues just like nanoplastics can. So humans are making a lot more of them now, but nanoparticles exist.
But is it possible at least to filter the microplastic from Cologne? Yes.
Yes, that could be done.
Why nobody doing this?
Well, you mean the really small like fibers?
Yeah.
I don't know. Phil probably knows more about that than I do.
I can give an answer, or I try to give an answer, because I visited a conference 2 weeks ago that dealt with these questions, and the experts on filtration of wastewater say, okay, we have 3 steps of filtering in a wastewater treatment plant in Germany, and they say it's good enough, because what's the residue of microplastic particles or nanoplastic particles, they say, is far beyond 1%, and then it's good enough. So they will not do any more efforts to try to increase the filtration. That's what they say. So we have them to convince them that they should think about it. There are technologies to do it better on micro, but on nano it's really difficult.
Really difficult at this stage. Really difficult. Yes.
Have you found any new species or tiny little animals in the plastics?
That's a really good question, and it's one I get a lot. The trouble is we know so little about bacteria in general that every time anywhere in the environment, pretty much any time you sample a lot of bacteria, you're going to come up with some that haven't been described before. But what I do think is interesting is we see on plastic, plastic is essentially solidified, most plastic, traditional plastic is solidified petroleum, right? It's the same. And we do find some bacteria that are specifically adapted to breaking down hydrocarbons. So that's kind of interesting. But there probably are new species, but because bacteria adapt very quickly, but I can't say for sure that they're specific to plastic. Yeah, good question though. Yeah.
There's one very famous, I think, Dutch student, Bojan Slat. Yeah, he tried to filter some areas of the sea with this.
Yeah, I think they're out in the Pacific right now trying the first prototype.
Yes.
We're collaborating with that group a little bit.
Okay.
I always like to say that I think every effort is worthwhile.
Yeah.
Personally, I think the best, again, limited resources, where to invest them. I think the best use of limited resources is to stop it before it gets to the ocean.
Yeah.
That's my own personal opinion.
Yes.
But I think every bit helps.
Yeah.
Yeah.
What is plastic in rain water? Because we know sand from Sahara can carry with the clouds to Germany. What is plastic? It's too? Or?
Yeah, I think there's plastic, and they found it in Arctic ice and snow. It's in, rain coalesces around a particle. So if there's a particle of plastic, it just like a particle of a dust as far as the water is concerned. So yeah, I'm sure it's in rainwater too. Yeah. It's pretty hard at this point to avoid plastic on this planet. And it, again, identify priorities and do what you can to make the biggest difference the most quickly. That's sort of, I think, the best motto. I don't ever believe that I will be. I'm not a plastic-free person, because plastic is a great material. It's used for biomedical. It's used for airplanes. It's used for computers. But there are appropriate uses for plastic and inappropriate uses for plastic. So I think the thing is concentrate on the appropriate ones and say, look, plastic is too valuable to throw it away after using it once, right? It's too valuable, and we're not doing a good enough job recycling at this point. So we have to approach this problem from many different angles, I think. Yes.
I read about one bacteria who is able to eat and digest microplastic. Is this true or not?
It is true. And I will follow that by saying it will never be a solution for environmental plastic. Yes, and the same with compostable plastic. My wife is an expert on, she's working on biodegradable plastic. That's one of the topics she's focusing on. Compostable plastic, whatever you want to call it. Those plastics are designed to break down, and the microbe that eats plastic will work in a specific controlled environment where you keep the conditions just the way the organism wants it, and you don't let other organisms in there that compete. When you put compostable and other plastics in the ocean, the standards that they have don't really apply to conditions in the ocean. The ocean water is relatively cold, it's relatively low in nutrients. So yes, I think that's interesting from an industrial point of view. It might be a solution for certain criteria, but there will never be, like, the solution is to sprinkle the plastic-eating microbes in the ocean and then say it's fine to just throw things in because the microbes will eat it. They found that out with oil. 10 years ago, 15 years ago, like, oh, we found this bacterium that digests oil. We'll just put it on oil spills and no problem. But, of course, it doesn't work. Yes?
Eric, just a clarification. Are you speaking of the same as oxo-biodegradable? Because that's quite popular, the oxo-biodegradable.
Right.
Is it the same as what?
Yeah, I'm not an expert in that, but my understanding is oxo-biodegradable really is just fragmentation.
Exactly.
So it sort of makes it disappear, but it doesn't really address the polymer itself.
Right.
I'm talking more about, when I say biodegradable, I mean things that will actually break down into carbon dioxide and water over time. That's
and these are more of the
yeah, there's things like polylactic acid, PBA, pH, those kind of things, which again are not perfect, but I think, again, I don't think bioplastics are the magic bullet that's going to solve our problem. There was this terrible thing in the United States at one point where they're basically advertising, the plastic things that hold 6 bottles together. And they're saying, oh, it's biodegradable. Did you see that? And then the turtles eat it. Did you see that?
What?
Yeah.
Yeah, we saw that.
Yeah. And I was like, no, that's not the solution.
Exactly.
So I think, but I think it's part of the solution. I think for certain applications it might be worthwhile, but it's not the entire solution. I don't think they use that advertisement anymore, by the way, but it was out there for a while. Great questions there. People probably have to go to the bathroom now. All right, well, thank you very much for your interest and your questions.
Yes. Thank you all for being here. Thank you, whoever was on the internet and joining us. Let us know later, Carol. Thank you very much, Eric. It was really cool, love that. to have you here from the Philippines.
Yeah.
How better could it be to show that the problem is the Thank you, Manfred. Maybe personal, I really love to see that so many people are really interested in it, and to see these people are really talking about plastic, they see the problems about single use, and it gives me just hope to see so many people around the world are active on that. They ask about nanoplastics, while people before didn't even thought about plastics. So I really love to see that, and I just want to say, keep up the good work. Be active, yes. If you want to join us on the ship tour, if you want to be active on that, we have a petition on it, to address the monster, to bring it back. Just stay in contact with us. We will have another talk tomorrow here on the same time. You can join us on the internet, or you can be here. It's about alternatives, because we want to show you, that's the problems, and we show you what are the research we're doing it. But we think it's not just enough to address the big companies. I mean, that's important, but we find out with Greenpeace, or it's also my personal experience, if you want to go, if you want to change something, you have to show it's possible, And when I go out there and I see, I talk about, don't use plastic, it's so hard, it's so complicated, and then companies are saying, nobody will do it, And they say, everybody do it. You see, there's a fucking great zero waste community out there. There are people who are doing it, and then you can say, okay, politicians, there are people who are doing it already. There are companies who can do it because people will use it, and then you can change it. So I think we all can work together on that. So, and tomorrow we will have a lot of people here, zero wasters from Germany, zero wasters from Cologne, especially. We have Mercy here will tell us how that all come together, how that is all connected.
Abby will be here.
Abby will be here as well.
Yeah.
Abby will be here as well. We will know more about Abby tomorrow. I would love to, if you come over, join us in the internet or wherever you want, and join us on that whole zero waste journey, and go with us, because we say there won't be any excuse for single use anymore. That's our mission for today.